Now we use a simple input example to go through how the merge procedure will correctly merge the two subsequences into one complete sorted sequence. Let's assume that our input sequence looks like this way. So this is the A of our input sequence. Okay, so the input sequence, it could be a segment, right? It doesn't need to be has the 1 as its starting index. Okay, it could be in the middle of something else. Okay, in the middle of a longer screen or of a longer sequence. So here's our P. Okay, the P has the index value 9, the Q is index 12, R has the index value of 16. And the number here in the grid is the value of the elements. Okay. So we focus on the last part of the merge sort code. So everything before is more about initialization. We count the length of the two segments. We allocate the memory space for the two sub-arrays, and we initialize them with zeros and appending the sentinel values as infinity and stuff. So the key actually, the operation starts from here. So we have a loop counter K for this for loop. The K starts from P and iterates from P to R. Okay, basically everything in the A. All right. So initially, P is the K is 2. So we will need to compare and the initial values of the other counters, J and I and J here, they are all 1. So that's the counters for the two sub-arrays. Okay. So initially we are comparing L1, which is 2, and R1, which is 1. Okay. So we choose the smaller one. Basically, R1 is smaller. So the else condition satisfied, we will need to copy the elements in R1, which is 1, back to the current AK in the input array. So these two will be replaced by the 1 here, and the J counter will increment by 1. Okay. So in the next iteration of the for loop, the J moves here, increments by 1. Right. The J increments by 1, and the original A1 is replaced by R1. Okay, it becomes 1. And the K also moves 1 more to here. So now we will need to compare the new Li and Rj. Okay, so we are comparing the element here and the element here. Okay, so according to the rule we set that if the Li is less than or equal to Rj, so the if condition will be, the if branch will be triggered in this iteration. So this time, the L1 will be copied to the position here. And then the I will increment by 1. Okay. So in the next iteration, I moves to the second, I moves here, and K also moves on. And the second elements in A will be updated, right? So the next K points here, and then we'll need to compare the two values here, which is 4 and 2. And then we copy the smaller values here back to K and increments J. Okay, so this is a quite similar steps if we go through 1 or 2 iterations. Okay, so we will go through the next couple of steps very quickly. Okay, and J moves on to 3 and a smaller value copied to A, right? And then J moves on, okay? and then j hits the 6, and then I moves on to 5, okay, and then 6 is smaller than 7, so j will move on, okay. So after j hits the sentinel values at the ending position, so everything, so that means the R sub array is done. We're done with R. So everything left in L is smaller than R. So that means in the iterations afterwards, everything in L will be directly copied to A. Okay. So here's the last elements. So at this point, the for loop ends because all the elements in the for loop has been iterated. Okay, and they are in a sorted order. Okay, from 1, 2, 2, 3, 4, 5, 6, 7. They are all sorted order, and that means everything in L and R, they are copied back to A in the sorted order. So that's basically a example showing a simple example showing the correctness of the basic merge steps, the merge procedure. Okay, so I would like to stress this again. We have implemented a merge procedure, but we are not done with the merge sort yet. So with this merge procedure, we are able to carry out the merge sort algorithm, which relies on this procedure. So for the formal proof of the correctness, we will rely on something called loop invariant, which we have introduced a bit for insertion sorts, but that part is optional. So I will make another video talking about how the loop invariance in merge sort looks like for optional reading.